So that is just a quick example of previous section. We want today study something called one-sided limits. Let's say I have a function at point A. Well, things are this way. Remember that yesterday when we were talking about limit as x approaches to A, we were talking about all the values from left and right when we are approaching to that number. Now, we want to be able to split this in two pieces. I'm approaching to A from the left. I'm approaching to A from the right. So, limit of f of x, x approaches to A from the left. This is the notation. This means what? This means that when I'm trying to evaluate this limit, I'm going to completely ignore the values on the right-hand side of A. And I look at only the values on the left-hand side and see what happens as I get closer to that A from the left. So approaching A using values less than A. So I'm just studying those ones. And, well, I could actually do the other way around as well. Limit of the function as x approaches to A from the right. And this time, I can ignore the left-hand side and just focus on the values of x on the right-hand side. So approaching to A using values larger than A. That notation, x approaches to A minus, x approaches A plus, this is part of the game. You have to understand the notation, and you have to understand that this is different than if I write limit of f as x approaches to A. So there are three different things. Well, let's quickly check a few examples because you know how to evaluate limits. I will draw a graph first. Say, okay, this graph goes all the way here. At 2, I have this value, say 2. At 1, I have value 1. So tell me what is limit of f of x as x approaches to 2 from the right. Tell me what is the limit of f as x approaches to 2 from the left. How about this one? Limit of x minus 1 over x minus 1 as x approaches to 1 from the left, as x approaches to 1 from the right, from the left, sorry. Simple ones. Go ahead, please. I'll give you 1 minute. When you're trying to write down the answers, focus on how the writing goes. I know that you know very well these things. I want you to focus on writing and making sure that you're showing all the steps, all the things that make sense to you. You had a question before? Is good? Okay, so remember that there's a negative sign there. Go ahead, please. 1 minute starts now. And you always feel free to talk to the person sitting next to you. 20 seconds left. The graph one is basically you checking your intuitive understanding of limit. And again, here, when you see x approaches to 2 from, or 2 plus, that's how we write, means from the values bigger than 2 or from the right, so you can ignore the graph of function for all the values less than 2. And in this case, you see that as we get closer to 2 from the right, the values of function gets closer to 1. From the left, you ignore the right-hand side. As x goes to 2 from the left, values of the function gets closer and closer to 2. The second one, the second example, this is mostly of how you need to write these things. I want you to focus on this. Please, please make sure that you are writing all these steps properly. Your work shows the flow of your writing shows your flow of work. Here, the first thing I will note here is that when x approaches to 1 from the right, that implies that I'm only working with x values which are bigger than 1 and close to 1, something like 1.1, 1.01, or something like that. Small numbers. I'm getting close to 1 from the right. That means that this x is going to be bigger than 1. So bigger than 1 minus 1, this is going to be positive. Absolute value of a positive number is the same number there. So here, x is bigger than 1, so I'm not evaluating limit yet. I'm not evaluating limit. I'm just looking at the restriction given by limit and rewriting my formula. So x minus 1 over x minus 1. Okay? Similar to the regular limit, when you're approaching to a number from the left or from the right, you ignore the value of the function exactly at that point. In other words, no matter from which direction you're getting closer to x, you are using all the values, but the point there, which is 1. So x is not 1. Why do I need that? If I know that x is anything but 1, right away I can say that, oh, based on this limit, I am going to have non-zero factor up there, non-zero factor down there. So I'm okay with canceling it. So I can cancel, and I get 1. Remember, canceling sometimes erases the information. But if you're sure that what you're canceling is not 0, which is the case, then canceling is all right. So in this case, I cancel, I get 1 constant function. Doesn't matter from left, from right, doesn't matter to what number you're approaching, it's going to be, the limit is going to be the same constant. Well, the same story I want to run for this one. When I'm approaching to 1 from the left, I'm dealing with values less than 1. Less than 1 means something like 0.9, 0.999, and so on, yes? No matter which one of those ones you plug into this, because x is less than 1, x minus 1 is going to be, x minus 1 is going to be negative. Absolute value of negative number is, or I will multiply that number by another negative sign, yes? We will see this lots of time, that you are doing these operations, you're dropping the limit earlier. Remember, what I did here, it's not evaluating limit. It is about defining the formula for my function. So that's why the limit should stay there. Now, I can cancel y because x is not 1. So then I'm dealing with constant function -1. Limit of constant function, no matter from which direction to what point, is going to be that same constant as the result of the limit. Any questions, any comments for me here? Yes, please.
No matter whether we have the negative in the numerator or denominator, right? The numerator, but technically be denominator.
Oh, you mean if the limit was like x minus 1 over absolute value of x minus 1? Is that? Yeah, it doesn't matter that way. It doesn't matter, yes. Any other questions? Let's do this question. This is an interesting one. The function is 2x minus 1 as x is bigger, not equal to 2. When x is equal to 2, say it is 1. Find the one-sided limits of this function as x approaches to 2 from left or from the right. Go ahead, please. 30 seconds should be more than enough. Make sure you're moving slowly. I know that's from the high school, you know lots of these information, but focus on writing. Focus on the concept and communicating your ideas and your thinking. Ten seconds left. As x approaches to 2 from the left, so we are dealing with values of x which are less than 2. And when I look at this, okay, so this expression will do this work for me. I am refining my function into a formula that I can use in evaluating my data. Well, in this specific case, actually, the same formula will work for x, for the limit of x approaching to 2 from the left. Why is that? Because the way the piecewise defined function is defined, this is working for all x's but 2. When I'm trying to find one-sided limits, I ignore that value 2, and the rest, I'm going to work with all the values of this one. Well, in one case, for only x is less than 2. In another case, for x is bigger than 2. But what does it say is that, well, this is going to have the same formula for me. Does that make sense? Yes or no? Any questions? Any questions? Then, okay, how am I going to evaluate these limits? Give me a way or show me how now I can evaluate those limits. Yes, please.
Value less than 2 to limit of x.
Oh, you mean the table of values, you mean. Yes, table of values will work, but yesterday when I was teaching the table of values, I said that I'm not going to get back to it. This is just a beginning story. What other tools we have that you can use that? Yes, please.
Direct substitution law?
Direct substitution. Did I cover direct substitution law for one-sided limits? No. What else? Yes. Limit laws. Did I cover limit laws for the one-sided limits? No. Well, I didn't cover, but I will cover now. Quick. Fact one, or I can write as theorem, or whatever format that makes you happy. Fact one is limit laws work for one-sided limits as well. It also works for one-sided limits. In other words, here I can write limit of 2x minus 1 difference or subtraction law as x of, oops, as x approaches to 2 from the negative side, and limit, this is constant multiple law, as x approaches to 2 from the left of x minus limit of 1. And then, well, this is just x. As x approaches to 2 from the left, x is approaching to 2. So this will give me 2 times 2 minus 1, which is 3. The same story will work for the right-hand side limit. You have to write down, or based on the facts that we have been seeing, the direct substitution works, substitution of polynomials and rational functions work for one-sided limits. Well, that's just part of the game. So now you know that you can use the laws for one-sided limits. But there is another important fact that we want to relate these 3 different limits to each other. How are the left limit, right limit, and the actual limit, or the two-sided limits, are related? And this is the fact, or the theorem from your book, says that they actually are closely related. The way I will write this down is this, that limit of f of x as x approaches to a exists if and only if. So it means that I can start from this, do the other one, or do the other one and come back. If and only if left limit as x approaches to a exists, right limit as x approaches to a exists, and their values are the same. Or if I want to write this a little bit more clear way, is that if limit of f as x approaches to a from the left exists, limit of the f as x approaches to a from the right exists. And there are three things. The left exists, right exists, and they are equal. I'm sorry for the ones that are back there, but this says they are equal. Then you can conclude that limit of the function exists, and the value is the value that you found for the left and right. So this is L, say. So that gives us one thing that we will use, especially when it comes to the piecewise defined function. When your function has different formulas around a point, you try to use one-sided limits, see if both of them exist. If they are equal, then you have calculated the limit of that function from the right, for the not one-sided limit, the actual limit. For example, the examples that we had here, right limit as x approaches to 2 exists, left limit as x approaches to 2 exists, they are not equal. Then what can we say about the actual limit? Does not exist. For this one, the right exists, the left exists, they are not equal. So that means that, oh, I went the wrong way. That means that limit of x minus 1, absolute value, as x goes to 1, does not exist. How about this guy? Left exists, right exists, they are equal. So then the limit of f of x as x approaches to 2 is the same number. So add one more tool to your tools, that when your function has different formulas around a point, when you're trying to find the limit, split the limit into 2 pieces, left limit, right limit. If they exist and they are the same, then the limit of that function at that point exists. Any questions? Any comments for me? Let's do one example and then go from there. Find the limit as x approaches to 1 and as x approaches to 0. What is the function? F of x has these values. X squared plus 1 over x minus 1 for x's, for x bigger than 0, it is sine of 1 over x. For x's less than negative 1 is 2x plus 3. So this function is given. If x is less than negative 1, it is given by that. If x is between negative 1 and 0, it's given by that fraction. And for x is bigger than 0, it's sine of 1 over x. evaluate limit of this function as x approaches to 1 and when x approaches to 0. Go ahead. You have 1 minute. Focus on your writing. You should write your solution in a way that a third person can mark it and you get full mark for it. Yes? Go ahead, please. 1 minute starts now. Thirty seconds left. Okay. So I'm trying to find limit of f of x as x approaches to -1. See, always in some versions, there is this step. Sorry, what was it? Oh, did I ask for 1? Oh my God. That's so bad. It's now fixed. Okay. I'll give you another 30 seconds. Go ahead, do it for -1. Wow. You're right. Okay. Do it for -1. Five more seconds. See, this is the key step here. When you're trying to find limit of this function as x approaches to -1, you notice that, which one I should use here? And if you get to that question because of there are more than one formula, the function is working based on more than one formula on different domains, then it means that split it and use the left and right. So instead of working on the limit itself, since I don't know which one to choose, I am going to restrict my work only for -1 from the left and only to -1 from the right. Negative from the left, from the right. Why is this going to help me? Because if I'm approaching to -1 from the left, this means that I'm working with this formula. So this will give me 2x plus 3 as x approaches to -1 from the left. Then this is direct substitution. And this will be 2 times -1 plus 3, which is 1. I'm not done. I have to check the right limit as well. So in this case, I'm working with x is bigger than -1. Wait a minute. If x is 2, can I still say that x is bigger than -1? Isn't 2 bigger than -1? It is, yes? But then that means that I can either use this one or that one. What is wrong with that way of thinking? Why being bigger than -1 doesn't include the third case in this case? While I know that if something is bigger than 0, it's already bigger than -1. Should I be worried about that thinking at all?
No.
No? Then which one I should take then?
You should take the one that's closer to negative because you're seeing what's approaching.
Thank you. When I'm approaching to -1, this is just one way of seeing it. I'm not worried only being bigger than -1. I'm worried about being bigger than -1 and getting as close as I can to -1. Yes, these values are bigger than -1, but if I want to get close to -1, I have to break into this interval. That's why I will need to use the interval that satisfies x bigger than -1, and it is closer to -1, which will mean this one. So this means and that implies, again, I can use direct substitution rule here, -1 plus 1 over -1. So the left and right limit, both of them exist, but they are not equal. Means that, so I can take these two guys and conclude from them that limit of the function as x approaches to -1 does not exist. How about the other one as x approaches to 0, split into two pieces? Why? Because function is defined using completely two different formulas when we are closer to 0. So I will consider when x is approaching to 0 from the left, I will consider x limit as x approaches to 0 from the right. First, refine the formula. I have to plug in something into f of x. I cannot just write it like as is. This, in this case, will be, OK, I'm using this formula. And then, because of direct substitution rule, I'll have 0 plus 1, 0 minus 1. That is negative. Yes, please. Oh, no, I'm using the negative part here. Yes, I'm using negative one. Thank you. This one is negative, yes. For the other one, the function is defined. So for x is bigger than 0, the function is defined by this formula. What is limit of sine 1 over x as x approaches to 0 from the left or from the right? Huh? What did happen? I cannot hear. X cannot be 0, but x can approach to 0. Yes? X can be small numbers getting closer and closer. Yes, yes, what is that limit? Sine of 1 over x as x approaches to 0. Did you already forget that? Yes. Does not exist. Can you remind us why?
It's like the graph is like
Do you remember the graph yesterday? Painfully, I was trying to show you how oscillating it is. Did you already forget it? What? Yes, this is that oscillating graph as it gets closer to 0. On both sides, it was oscillating. So that's why this does not exist. So one of the one-sided limits does not exist. That means that limit of x approaching to 0 of this function does not exist. Okay. Obviously, I don't have enough time to cover the second thing, but I will send you home with the plan for first part of tomorrow. Oh, tomorrow's Saturday. I'm not coming here. If you come here, you're on your own. Okay, don't go anywhere. Don't go anywhere. Remember the quotient law? Remember the quotient law? Okay. When you come across such limit, f over g, the first thing you should check is, can I use quotient law? Means that, is the limit of the denominator as x approaches to a is not 0. If it is not 0, I can use quotient law, which means that that limit can be calculated as quotient of two limits. That already we know, that's the quotient law. But what if limit of the denominator is 0? What will happen if the limit of the denominator is 0? Well, you need to do one more work to be able to say what is the result. If after you see the limit of the denominator is 0, one thing you should note that I cannot use quotient law anymore. The second thing is that, okay, now let's see what is the limit of the numerator. Is that also 0? If the limit of denominator is 0 and limit of the numerator is 0, we call this 0 over 0 indeterminate form. 0 over 0 is not final answer. It is the beginning of a story. It just tells you that now you have to do some work to resolve this indeterminacy. And that's something we will cover tomorrow. If the limit of the numerator is not 0, so numerator is a number, not 0, denominator has limit 0, that means that numerator gets close to a number, non-zero number. Denominator gets smaller and smaller. If denominator gets smaller, what will happen to the whole fraction? It will increase either plus or minus. So that's where you will get infinite limit. You come back tomorrow. First, oh my God. Or maybe we should come back. How about that? Have a great weekend and see you all Monday.